So this is our general notation. The A out in front is the idea of our slopes, the left and the right side. This is the X coordinate of our vertex. This is the Y coordinate of our vertex. So that's the general form. So know that tomorrow. I allude to that a little bit tomorrow, is that notation. So that when we now go to fill out this equation, if we look at our slope on the left, on the right side, we're going up one, right one, up one, right one, up one, right one. So the slope over here is always a 1. On the left-hand side, it better be a -1, which it is. We're going down one, right one, down one, right one, down one, right one. So that slope is a -1. So that's our A. Since this opens upwards, we should end up with a +1 right here. So whether you write the 1 is up to you. It doesn't necessarily matter if it's a 1 out in front, but for the visual, I like to put that. When we look at our vertex then, so here's the vertex point. This is 1, 2, 3, so -3, and then we go 1, 2, 3, 4 down. So that's our vertex, -3, -4. So the -3 is your H term, so that's what we're going to put into that spot. And when we do that, that double negative that creates, so that this now becomes an X plus A3. If we know we have a +3 in here, we would know that our X coordinate over here is negative. And then the K is your Y coordinate. So we're going to slot in this -4 right here as a -4. That's our absolute value equation. All right. Then the piecewise function is one I'm a little more worried about. We've done a lot more practice of this recently, but the previous times I've given you this hasn't been so good. So hopefully tomorrow we'll have this squared away. So we should have 2 different lines. So we're going to do one line here. You're going to do one line here. The first line has a slope of a -1. So that one's going to start with a -1. And then like I've said before, if I know what this one looks like right here, this is going to look very, very, very similar when we just put this into point slope form. We have a -3, so we would do X minus a -3. So that's X plus 3. And then since our Y coordinate is a -4, you're going to put a -4 right here. Look how similar these are, right? X plus 3, -4, X plus 3, -4. All right, they're pretty much identical. One is bars, one are parentheses. If we understand that, we go to the next one, and it's now a slope of a +1, and we'd still have X plus 3 minus a 4. We need to be able to define our domain with these. All right, so if I now go to define this domain, this one is any value to the left of -3. All right, that's the X coordinate at this point right here. So we would say all X values that are less than or equal to the -3. And then the other side over here, when our slope is a +1, that's when we're to the right of the -3. So we want all X values that are greater than -3. All right. So certainly we'll need to be able to do that tomorrow. Okay. So hopefully we can do that now, especially this piecewise function. Now let's see if we actually remember this. We've done this a ton, but it's not necessarily we've done it with this type of a question worded in this way. All I want you to do is write the equation of the line that gives this information. I want it in point slope form. What we just did up here, this is point slope right here. This was point slope form that we just wrote it in. So point slope form is the whole y equals, and then we're just going to be doing the same thing we just did up above. The slope is easy in this one. I just flat out give it to you. So if I tell you that your slope is 35, you're going to put a 35 right there. So let's do that. And then we do X minus whatever our X coordinate is. The X coordinate in this one is a -10. So if I place a -10 in for that little X sub 1 notation, that means I end up with a +10. And then the 4 is my Y coordinate. So that's just what we're tacking on at the end. We've been doing this exclusively with the vertex of the absolute value. We can do this with any point we want. Okay. So with this one now, our issue with number 3, if we're going to be putting this into point slope form, the whole idea with the name of this is you need a point. We have that. We actually have 2 of them in this case. But we also need our slope, and we don't have that for this particular problem. So this is then us just revisiting this guy, the old slope formula, change in y over the change in x. The y sub 2 just tells us that we want the y coordinate in the second point. That's the -4. So we're going to do -4 minus. The y sub 1 means we want the y coordinate in that first point. That's an 8. Say that one more time. What's that, Ahmed? Now he's frozen. If you pop back in, Ahmed, if you can hear me, let me know. I didn't catch that, and then I think you're frozen right now. Oh, now he's moving. No, he's not. Okay, I'm going to go ahead. Yeah, all right. So the x sub 2 is going to be a 7, and then my x sub 1 is going to be 3. The numerator then becomes a -12. 7 minus 4 is 3. What we then find is our slope is a -4. And then it's the same thing we would have done before. When I now go to write this equation, I now know my slope was the -4. I then do x minus, pick either one of these 2 points. Doesn't matter which point you pick. I'm going to use this one. I'm going to use 3, 8. So I would do x minus 3 and then plus my 8. Okay. All right, these guys. We just did a little quiz on this last week. So we'll see how this goes tomorrow. Keep in mind, absolute value equations most of the time have 2 answers. They can have 1 answer, and these we can have no solution. So our goal with these is to always get these little absolute value expressions all by themselves. So in number 4, that's already done for us. As long as this is set equal to a positive number, which 21 is. Okay, thanks, Ahmed. Yeah, you could definitely graph them and count. Yeah, we could set up a table as well and go down our table left and right. All 3 of those are nice visuals. All right, so our absolute value equations, as long as this is set equal to a positive number, you're going to get 2 answers. And we just said we're going to take this 2x plus 5, set it equal to 21. But as long as we equal a -21, the absolute value would still give us a positive 21. So we set that up, and then we just, wait, if I do it correctly, this should be 2x plus 5. And then we just solve both of those equations. So this one should end up with 2 different answers. So subtract your 5. Divide by 2. And one answer is x equals 8. If I take the 8 and plug it in, that's what's going to give me a positive 21 inside those absolute values. The other side, if I subtract 5, we now get 2x equals a -26. Divide by 2. -26 divided by 2 is a -13. That's our other answer. If I plug in a -13, that's going to give me a -21. But since I do the absolute value of that, that will give me the positive 21. Okay. Now, step 5, or number 5, now we have a few steps before we can do what we just did in 4, because now we need to get this by itself. So we need to get rid of the 4, we need to get rid of the 10. So the first thing we want to do when we solve any equation is undo the addition and subtraction. So we're going to subtract that 10 over. You could distribute here if you want. We haven't done that. I wouldn't necessarily advise that, but it'll definitely work. We've been just dividing by 4 so that we get the absolute value of x minus 8 set equal to 5. So again, at this step right here, notice how this is set equal to a positive number. We should get 2 solutions out of this. And those 2 solutions come from us saying x minus 8 set equal to the positive 5. And then the x minus 8 set equal to the -5. Both of those we just add 8. So one solution should be 13. If I add 8 to the other one, the other solution should be a positive 3. Okay? All right, so those are our absolute value equations. Number 6, go through that guy. Same process. We want to subtract this 14. so that's going to equal 2. And then I'm going to divide by the negative 2 that's out in front. So these will cancel. And then I get this absolute value of x minus 8 set equal to a negative 1. All right, good. Cam recognized it. We want to recognize it at this step. If you don't recognize it at this step, that this is a no solution. So the answer to number 6, right now we're done. This is a no solution. You don't do any more work. You write that down. You look for that answer. However, I ask that question tomorrow, if you get one of these, that's a no solution. Where you need to be careful is we could continue on right now. There's nothing stopping us and say x minus 8 equals a positive 1. You're going to get 2 answers out of this. And I promise if it's multiple choice, those are going to be 2 of the answers that you can choose from. So you need to recognize at this step, this is telling us that we have no solution. There is no way that I can take the absolute value of something and get it to equal a negative number. All right. Okay. Now, 7, just be careful. Notice how we have it set equal to a negative, but we don't have these absolute value bars isolated, because when we now divide by this negative 4, it's this step right here, when it's by itself, that we evaluate if we get our answers or not. And since this absolute value is set equal to a positive 10, now we are going to get 2 different answers. So now we can go ahead, set up our 2 equations. Oops. And then solve these. So one should be 7, and then the other answer should be a negative 13. All right. So real quick, answer number 8. Instead of me giving you equations to solve, write down an absolute value equation that if I were to look at these, if we were in our presence together, I would tell you, yes, that equation would have a no solution to it. So that if we see one of these tomorrow, we would know that is the answer. All right, got one, Cam? What do you got? Oh, you got deep, Cam. Although I don't know why all this is lighting up right now. And actually, after all of that, I might have bad news for you, Cam. So this is what you have right now, 2x, negative 2. Yeah. Subtract. Why is my camera doing this right? Why is my ink pen doing this? I like it too. I mean, that's going above and beyond right there. So watch what's going to happen here. This gives us a negative. So let me just recopy it on this side. Our next step is then to divide by a negative 2. And what we now have, now our guy's all by himself, right? But that is ultimately set equal to a positive 3. So this actually does have some solutions. So how could you fix that? Yeah, good. So let's just change this to a positive 2. So now when I divide by a positive 2, we get this to be a negative 3. Now we would say that has no solution. Okay, good. I was just looking for something like this, Cam. I like it though. Just set this equal to like a negative number, and that would be it. There you go. Ahmed's got one. So recognize those tomorrow. Okay, if we have time, we're going to do this. We did these yesterday. Certainly something I want to make sure we can do for tomorrow. But I want to make sure we do 13 and 14 first, just to make sure we get these types done, since we haven't done these in a while. Now, what you want to be careful of with 13, I want you to write a piecewise function for this. However, there is no mention of this being an absolute value function, so don't make assumptions. If I tell you it's an absolute value function, then we can do that. If not, we don't want to assume that. We'll verify it right now. So even though we have this shared point, notice what the slope of the one on the right is. It's down 1, right 2, down 1, right 2, down 1, right 2. If we go to find the slope of the one on the left, we're going to go up 2, right 1, up 2, right 1, up 2, right 1. Is that the relationship these would have if this was an absolute value function? No, they should be the same number. So they're either both 2's or both 1/2's, but they can't be two different numbers. So this is not an absolute value function. That doesn't mean we still can't define these two different equations here. All right, so we're just going to write these two. This is now our point slope. Same thing we've been doing. So if I now go and write this out in point slope form, the first line, I'm going to do the blue one first since that's the one that appears on the left. The first line has a slope of 2. You can use any point you want. So before we had V's, I would have drawn all these points in and I would ask you what point to use. To make this easy, I would still just stick with the vertex. It's what we're most familiar with. It's what we've been dealing with over and over and over again. But you really could use any of these points if it's not that absolute value equation. All right, but we'll use the shared point, 0, 8. So the x-coordinate would be 0. The y-coordinate is 8. That is our equation for any x value, since this is occurring right here at 0. Ooh, this might be a little... You know what? Let's do this. Just I won't try to get you on this tomorrow. Let's put some arrows on these so we say these go on forever. We won't add that layer to this. The first one, that is for any x value that's less than 0. So we'll say less than or equal to 0. When we go to write the second one in point slope form, our slope we've already identified to be a -1/2, so you're going to put the -1/2 right there. The x-coordinate, this should now be the same as these up here, right? If we use the exact same point, these should look the same. So we're going to do 0 plus 8. And then now this is to the right of the 0 right here. So these are all x values that are greater than 0. All right. Okay, I had you do one of these on your last quiz. That's the previous quiz, the 4142, and it was just kind of iffy. So that's why I wanted to make sure we did one more before tomorrow. And then same with these. This was on your last quiz, this type of a question, but we haven't really dealt with it since. So let's see if you remember all this. So it says, when he was on vacation in Michigan, John went for a bike ride around Mackinac Island. The following piecewise function represents the distance he traveled in miles on the number of hours that he on his journey. Use that function to answer the following questions. So find f of 5. That should be easy. We did a bunch of those, but we haven't necessarily talked about the meaning of this if I ask you that. So find f of 5 real quick. And then write down what you think that means in relationship to the question. All right, what did you get for f of 5, Cam? Good. Which one did you use? The first, second, or the third? Good. So 5 fits in this window. So we're going to plug it in right here. And when we did that, he said we should get 41. So that's good. All right, we just get 5 times 1, which is 5, add up to 36. And then what did it mean? Not quite. That's what I just changed up here. So what this gives us, this is how long his trip lasted. So his trip lasted 6 hours. This was the first 2 hours. This would give us our distance anytime in the first 2 hours. This is the third and fourth hour. This would give us our distance, and then our final couple of hours are in that window. So what we've just found, we did deal with minutes. What this means is at the time of 5 minutes, because 5 get plugged in for, I'm sorry, hours. Sorry, confusing myself there. There we go. So after 5 hours, John had ridden 41 miles. This is our mileage. So the left-hand side of this piecewise function gives us our total miles. The right-hand side gives us our total time. All right. All right, this question, see if we remember this. When is John riding his bike the fastest? During which interval? So you're either going to say 0 to 2, 2 to 4, 4 to 6. All right, this was a bit of an issue initially. I think on the quiz we handled this reasonably well. Riding his bike the fastest is basically his rate of change. It's his speed. These are kind of the real world words that we would use for us in math class. All it is your slope. That's what our slope is. It's our speed. It's our rate of change. It's how quickly we are moving. So if I want the greatest speed, I really just want the greatest slope. So here his slope was 10. Here his slope was 8. Here his slope was 5. So he's moving the fastest. He was going 10 miles per hour in that first interval. So we would want to say over the interval of 0 to 2, that's when he was moving the fastest. He's moving the slowest at the end because this would be 5 miles per hour, 8 miles per hour, 10 miles per hour. So 10 is the fastest, 5 is the slowest. All right, now answer C, Cam, just to make sure you're squared away with this. And I'm going to pull this up here. All right, how many hours did we ride our bike, Cam? Good. This is telling us how long we rode our bike. We started at 0. We don't have any gaps in here, so it's just 6 hours. All right, that's our total trip length. And the last one for me went to the wrong page. John covered, true or false, John covered a distance of 60 miles on his bike trip. I asked this question in a little bit different way on our quiz. So just worded differently, but something we've seen before. So what we want to know is, did he travel a distance of 60 miles? Well, what we could figure out is at the very end of his trip, so the end of his trip would be at 6 hours, wouldn't that be the longest time or longest distance that he would have traveled? So what this question is really asking is, how far did he travel over that 6 hour window? So what we would want to calculate is, what is f of 6? Because that's going to tell us our total miles traveled over that 6 hour period. So that's definitely this last function. So we're going to do 5 times x minus a 4. So 6 minus 4, and then plus 36. That then becomes 5 times 2 plus 36. That's 10 plus 36, which is 46. So true or false, did John cover 60 miles overall on his trip? No. This is how far he traveled in that 6 hour period. So that statement would be false. All right. So be able to answer some word problems, whether I give it to you as a piecewise function like this, or on the quiz, I gave you a little graph and I asked you a series of questions on the graph. Be prepared for either of those. All right. Those are definitely on there as well. All right. And then since we do have a little bit of time, let's revisit these. Do your domain and range real quick. Make sure we got that. Let's say that this one goes on forever. This one definitely does not. So we have a closed dot right here, and let's put some arrows on the end of this one. All right, domain should be your x's. And we're just going to go, what's the farthest left we go to the farthest right. So here's as far left as we go. All right, we don't go past this value right here. That's the x coordinate of a -1. It's a closed dot, so we want to bracket. And then in terms of how far to the right, since we've added that arrow there, that means we go right forever. All right. If I ask you your range, those are your y values. So we want to know what's our lowest y value. So that would be the lowest point in our graph right here. We don't go any lower than that red line. That red line goes through the y value of -2. So the range starts at a -2. And with this arrow telling us that we're always going to be going upwards, then we continue to go up forever and ever and ever. That's our range. Okay. All right. X-intercepts, I split these up now. So the x-intercepts right here, that's the x value of 3. And the y-intercepts should be the y value of -1. All right, 11. Circle which one of those we have, and then answer number 12, and then we're done. And then we'll see if we know all this tomorrow. So determine if there's a max or a min, and then what are their value or values. All right, Cam, take us home. What do we got, a max or a min? Good, so we only have a minimum. All right, because this thing is going to increase forever, so we never hit a high value. It just gets larger and larger and larger. When I ask you for the maximum or minimum value, that is always the y coordinate that we hit. What's our smallest y value, Cam? -2. And we can just go back to our range. This is the smallest y value. That's why we start our range off at that. And the fact that our range goes to infinity, that's why we don't end up having a maximum, because we just get bigger and bigger and bigger and bigger. Okay. All right. That's pretty much it. Wrap that up a little bit early. I'm glad we were able to get through all those. So look all this over. Test tomorrow. It'll probably be more points than our previous quizzes. So this will inflate your grade, hopefully in a good way, but it could definitely hurt the grade in a bad way, just because it's going to have the most points that we've had so far on an assessment, and that's 70% of your grade. All right. So if there's any issues, reach out, pop into class a little bit early tomorrow. If you did have any issues, I'll hop in a little early. You can ask a question. But if not, we'll see you then. Okay. All right. We'll see you guys. That is true. Thanks. Yeah, that's true. I'll give you 6 minutes.